Mhm. No, almost though. It's the one for this week. There's one more next week. I have another one that I just haven't seen. Huh? It's the current one.
That particular one in class today.
Yeah.
I have it somewhat written up.
Oh, good. We'll just ask you what to do. Hey, he's done already. Christian, I'm going to buy that guy a mic. Just send it to him. Do you know where he is? Can we buy him a $5 mic and send it to him? Your Java partner. I was listening to you last night thinking, how much is a mic? $5. You were doing so good. I was just like, thank you, thank you. You did great. You were awesome. I kept thinking, what is the problem with this guy? And then he turned in one from way back that he did by himself to kind of like recover some points. And in that one, he's typing away, and he types away that he's waiting on his mic from Amazon. So I sent him a reply on that one saying, I think Amazon lost your order. You might need to get the other one. So you are doing great. We'll try to do less of that because it's fun. Oh, we've got some good stuff to do today. Let's see. This little clicker thing does not like to work for me. Why won't you work? I guess it's just not installed right. Something's wrong. Okay. The first thing we want to look at today is the topic of generics. And it says generics help us get fewer overloaded methods. So before we look at this, what is an overloaded method? Remind me.
Similar method signature, but with different returns and error.
Custom. So two methods, same name, different either return data type or arguments or both. Exactly. So we can have an overloaded constructor. That's how we know we can have like a no-arg constructor or a constructor with multiple arguments. That would be an overloaded constructor. Well, sometimes if we have a method, like think about our sort that we did last time, we might want to be able to sort integers. We might want to be able to sort doubles, decimal numbers. Maybe we want to be able to sort all sorts of things with our awesome bubble sort code. So we could write a bunch of overloaded methods, you know, one that expects integers and one that expects doubles, or we could use generics. So generics are a directive that is interpreted by the compiler. So our generics look like this. So you've seen them. Try to get to this slide. You've probably seen them. You've seen them on Stack Overflow and other places where there's code that you've looked at. And a generic is just a parameter. So it allows us to parameterize our data types. So any place in our code that we would specify a data type, like int or double, we can use this generic specifier instead. It's like a placeholder for that. Then, when the compiler compiles our code, it will determine what data type should really be there, and it'll replace this placeholder with that data type, like int or double. Now, whenever we're working with generics, this is considered a formal generic type. What matters here are the greater than and less than brackets, the diamond bracket around it. We've started seeing kind of conventions develop that people usually use an uppercase T inside there to indicate a generic, but you'll also see them with the uppercase E a lot. And you could really use anything inside those angle brackets. It's just kind of evolved to be the T. Is there what? I think it's just that it's like an abbreviation of type. You know, that it's just a type specifier is kind of why the T is there. And like if in Java, they'll use E's more often, and I don't know why, because T for type makes sense to me. E doesn't really, but just whoever started doing it when they first started with the ability to use generics. So generics haven't always been around. So before generics were around, I could refer to everything as an object. So in my code, I might specify that I was going to sort an object instead of sorting an integer. Theoretically, that would give me a chance for a runtime error because, say, my code was handling everything like an integer, but somehow a double or a decimal value got in that mix. I could have a cancel situation when I truncate or when I try to do something that I can't do with that data type. So the generics allow the compiler to keep us from doing things like that, illegal things that would cause a runtime error. So our formal generic type is usually going to be the T or the E. During compilation, the actual concrete type, like int or double or whatever, is determined, and the generic is replaced by that actual concrete type. When this happens during compile time, that's called generic instantiation. We've determined what the generic should be, and we're replacing it or instantiating it. Now, when we're working with generics, a generic type specifier can only be replaced by a reference type. And a reference type in C# is an object, something that is an instance of a class. Now, when we're working with C#, lowercase int is a data type int, like a native data type. Uppercase int is an instance, a class object that holds an integer. Same with double. Now, we've seen that with string. You might have noticed it, but you can refer to string as a data type with an uppercase S or a lowercase because it's a synonym. C# just has that set. It's the same thing. Now, we could also replace a generic type with a type like football, like our object. So we could create an entire class that uses an object type of ours. Now, we can't replace a generic with a native type like int, double, or char, the lowercase values. We can do it. It's going to happen, but it's not really going to happen. Behind the scenes, the runtime system is going to be replacing this native data type with one of the class data types, and that's called boxing. That means this native data type is going to be auto-boxed in a class type object so that now it's an instance of an object. We'll talk a little bit more about that in a second, but realize there's overhead associated with that. Wasted runtime. So we have to be aware of it happening. Okay, so let's look at an example, sort of. Here we have a stack. And a stack is a data structure that is last in, first out. Here's our stack of plates. So if I have this stack of plates, I can't come over here and just grab this bottom one, right? I can't grab one out of the middle. It's a stack. Whatever I put in last is going to be the one I take out first. So last in, first out. When I would use a stack in the world of computers is a lot of times with programming. So if my program starts running, it starts running at its main module. My main module calls an input module. The input module is added to the execution stack, and control is transferred to that module. It starts running. In our input module, let's say we call another module that does some sort of data validation. When we call that validation, again, it's added to the stack of running modules, and control is transferred to that module. When our validate module gets done running, it's going to release control, and it's going to be removed from the stack, and control will return to our input module. When it gets done running, again, it'll be removed from the stack, and control will be returned to our main. So when we use a stack structure like that, it makes it very easy to return to our previous level. So we use stacks all the time in computers. Processor uses the stack with, you know, what's happening in memory, all sorts of different things. So We're not really at that point talking about stacks, but I want you to know a little bit about what it is. So let's say we were going to create a class that was a stack.
Isn't stacks what they use for like undo and redo operation?
That would work perfect too. Exactly. Very good example. So here's a generic class specifier. We said the name of our class is stack, and we're going to add a generic. The stack class is going to have a generic specifier. Now inside of our stack class, when we want to refer to some data array named items, we could say its data type is T, also our generic. Whatever this generic is getting instantiated as, be it an int or a double or a football or whatever, that's what this array's data type is also. Here we have an example of a method. This method's return type is going to be whatever data type that generic specifier is instantiated as. So again, football, int, whatever. Here's another method. In this method, we don't have any return data, but we do expect a parameter. We're going to call this parameter an item, but its data type is going to be whatever our generic instantiation is. So it gives us a whole lot of flexibility that we can use those generics to kind of make everything dynamic.
So do you have to say what it's going to be when you call them?
You do. So when you call it, when you create your instance of your stack, you're going to have to say, besides the fact that this is a stack instance, we have to resolve our generic at that point. So this is resolving our generic where we're saying it's going to be an int. And then after our new parameter, where we specify our data type again, we will specify that data type. In this example, this stack is also receiving a parameter. So notice how the greater than, less than arrows go in between the class name and that parameter, because it can be kind of weird to code as you start getting into it because you've got all of these additional special characters. So really just any place we specify our data type, we would specify that generic data type that we want to use. Now, because we've said this, when we call our stack to instantiate an instance of it, the compiler now knows what to replace all of those t's with. Okay, they're always going to be integers. That's what we'll replace those with. So that'll work out. Okay, there's a couple other weird things just thrown in this one. Make sure we got some information out for you. There is a data type called dynamic. So going along with generics here and things that can be really, really useful, a dynamic data type can store anything. So if I use dynamic as my data type, notice it's an object because it starts with an uppercase letter, right? So if I use dynamic, I can store any kind of data. Generics are resolved during compile time. The dynamic data type is resolved during runtime. So this is like Python, right? So instead of, we know C# is a strongly typed language, right? It just bit us right in the behind trying to come from a loosely typed language like Python, if that's where we came from. Then we know C# is much more strongly typed. Well, here's some loose typing. So if you use this loose typing, guess what? You're going to lose some performance, right? Because now the runtime system is going to have to be resolving and figuring out what data type these dynamic elements are as compared to already knowing because you had strongly typed that. So a couple of examples here. This int value would be resolved as an integer. This one would be resolved as a string. And again, at runtime. Now we also have a VAR data type, and the VAR data type can also store anything, any data type. So whenever we're working with VAR data types, those types are resolved at compile time, like the generics. So they would have less of a performance hit than the dynamic data types because they are resolved. So it just adds a little bit of overhead to our compilation. Because they're resolved at compile time, they have to be given an initial value when they're declared so that the compiler can decide what kind of data type they are. So we have to give them a value. We can't just have them allocated. Okay, so what's boxing and unboxing? All of these different data types that we're looking at, whenever we're thinking about something that's a native data type, it's strongly typed in our C# program. We said this is an integer. There's 100 occurrences of it in this array. Why do we have to do that? Why is C# so specific? Well, because it's going to take all of that information from our compilation and it's going to plan how it's going to allocate memory when this program runs. All of that memory plan is going to be allocated on a type of memory that's called the stack. So the stack is nice and organized. C# was able to plan out its stack while it was compiling. Say, oh, we have 50 integers. I'll get those all allocated. Now, on the other hand, if we create an instance of an object, and our object, we create 75 instances of that object, C# couldn't know that at compile time. So the instances of our object and the instances of any class object are going to go on the heap. The heap is a big old pile. It's a big mess, right? So we have a new object. We're going to throw it on the heap, throw it on the heap. We didn't know that that was going to happen at compile time. Okay, so we can think about them differently. So our stack is all organized. C# knows directly where everything is. It's all allocated directly to memory, all our variables. Really quick access. We need to access int A. C# knows exactly where it is in its memory map and goes and gets it. So this is like thread specific if we were multi-threading, because we were taking advantage of multiple cores, that would be okay. C# would take care of that for us with our different threads. Now, when we're looking at the heap and we're talking about objects like our football team or whatever, we're talking about memory that's being allocated in blocks. We don't know necessarily what size those blocks are, but if they're 4K blocks, we could be allocating 4 kilobytes every time we need something new on the heap, right? They're slower. A little bit of a mess out here. We got to go find stuff in this giant garbage heap. And these things are allocated in memory when our program is running. So they're specific to this application and this execution of the application. So all our objects and things like that are going to go in here. So if I have something like an integer named I over here in my stack, and I refer to it as a generic, or it resolves a generic, it has to be boxed. It has to become an object. So in that boxing process, it's going to be have some things allocated around it, and it's going to be copied to the heap. So anything that resolves a generic has to live here in the heap so that we can get to it. So boxing and unboxing is overhead, and it's the overhead involved in moving something from our stack memory to the heap memory. If we unboxed it, like we set some integer named I equal to this object named I, it would be unboxed and brought back over to our stack. So stack organized, heaps a mess. So bad programmers, remember that. A lot of times when you guys will run into it, because especially if you look at some of the Discord channels and you try to help some of the brand new programmers, there's always this progression. And at first in programming, it's like survival, right? Yes, get that if statement in there, get it in there. And then later we can start thinking about, is that really the best way to write that? Is there a more efficient way? So we have to be aware that this boxing and unboxing is happening behind the scenes, and it can cause some resource consumption for us. So overall, generics are placeholders that are resolved at compile time. They allow one block of code to process many different data types, and they prevent runtime errors by allowing the compiler to validate objects' data types during the compile. So any questions about those? Really important stuff. Generics are super commonly used, right? If you ever looked at a Stack Overflow solution that didn't have one, I don't know, but I know when you're first starting out, it seems like every Stack Overflow solution has one. But yeah, they're very, very commonly used. And that's an interesting thing because we won't have a lot of opportunity to use them. So it's definitely something that you should put on your list of things to practice, you know, just to mess with, to play around with. But once you start coding and getting out there, it just starts becoming second nature.
So are they like mostly helpful, or is it, can they get you into trouble? It seems like you could, by using generics, I don't know, like you're passing generic to a method or something, and you hadn't expected that data type to get in.
It's mostly helpful. And we'll look at this next one because so much information to get to you today. Let's look at this next one, and you'll see some in use.
The generics are able to like say, like if you're programming a function that takes in generic, are you able to say like, I don't want this specific type of thing. Like if your code would crash if you have a string, if it's a function specifically for like, you know, integers or doubles, say no string.
So if you get really involved, you can say that your generic has to be a number. Because, you know, like if bless you, if we look at our objects and we trace them back to their roots, like each object up to its parent, right before we get to the system object, we'll see the number object. And the number object is going to be the parent of double and decimal and int and all those different number classes. So,
if it's not a number, just get out of here.
yeah, if you start getting into the real advanced specifications, you can just say that it's a generic number. It has to be a number. You would be able to say it was a generic string. So as long as you're wanting to limit to a data type like that that exists in the C# object structure, then you don't have any problem limiting it. So you can say that that number defines all of those. So definitely gives you a lot of capabilities. In one place we're going to see them being used here are in some of the other C# classes that you'll want to take advantage of. So we have quite a few here. Some of these you need for the assignments that you have, or will help a lot with the assignments that you have. And some are just collections, and we're talking about collections. So some of the collections that we want to look at are the array list, the string, bit array, hash table, queue, and stack. So here's a collection. Do you know anybody that has one of those collections? Do you know any racers? You know those heads.
I bought a speed cube, but it still takes about 10 minutes. But
Does it?
It's nice to be able to go.
I had some former students who went to the race like in Kansas. They were humiliated, and they were super fast. So anyways, when I saw that, I thought, oh, that's so cute. A collection of Rubik's Cubes. I don't think I ever could do it. I mean, you know.
You could try a 1x1 Rubik's Cube.
Yeah, probably with Google now I could do it. Back when I was a kid, there was no answer anywhere. You just had to figure it out 20 years later. That's all right. Okay, so this is an example of what we might see as a collection class, right? A big old collection of things. So the classes that exist in C#, we call them predefined classes, just meaning that they're already existing in the system for us. And they let us use, store, retrieve, all different kinds of objects. To use some of the collection classes, you might need to add the using system.collections statement. So if you're trying to use one of the collections and it's giving you an error, you might need that using statement. Now the first one we're going to look at is the array list. And the array list is just like an array. It's zero-based, meaning that very first entry is index 0. And it's a list-like structure, but it can dynamically increase and decrease in size. So more flexible right away than an array, right? We don't have to worry about all of that. It also supports mixed data types. So a couple of those big things that are problems with arrays, we can use an array list and get away from those. Now, whenever we allocate an array list, we're going to start out by specifying it's the ArrayList class. Give our ArrayList an identifier or a name. Instantiate the new instance as an ArrayList object. Notice we have not specified a number, a size. Now the ArrayList, just like any other class, includes a lot of methods that are predefined also. So we can use these methods however we want. We can add additional ones. First of all, there's an add method. With the add method, we would put what we want to add within parentheses. So again, if you had Python for your 120 class, this is going to work more like an array did in Python, but it also lets you work with the array in the way that C# always has. So either way is fine. So you can put your square brackets and put an index number with an array list, and that'll work fine. Some of the other methods that we have, clear will clear out the array list. Last index of would return the index value of some data type that you're searching for. We could remove things, remove at, sort. We could even convert an array list to a standard array if we wanted to. So all of these methods are available for the array list. Now an associated class is the list class, and here's one that uses a generic. So the list class is zero-based like a standard array. List-like structure that can dynamically increase and decrease in size. It does not support multiple data types though, does it? It only supports one, but the data type that it supports is whatever you specify in that generic. So I could make that a list of football teams if I wanted to. So when I'm working with a list, I don't have to worry about that boxing and unboxing, because since a list is an object, all of the items in that list are already objects, and we're not going to have to worry about everything being boxed. Now to allocate something, we're going to specify that it's the list class. We're going to resolve our generic, give our instance an identifier or a name. Say we want to instantiate that list. And again, we have to specify that data type that we want to use to resolve our generic again. So you can kind of just think of it as part of your data type now. Wherever you specified just data type before, now you're going to specify that generic resolution. Does that make sense? Now, a string, remember a string, anytime you're working with a string, you're working with an array. So it's an object in and of itself. So the assignment you have, don't forget about that. You want to look at the string class and see what kind of methods are available with the string class. You know, can I just grab the last letter off that string? What can I do? Okay, so when we're working with a string, remember the string class, we're working with a collection of Unicode characters that will ASCII chart. The system has that predefined alias. So lowercase string is the same as uppercase string in C#. Whenever we're doing an equality comparison, normally, if we were comparing two integers, we would be comparing the reference location, the location in memory of those two integers. Are they at the same memory location? They must be the same, right? Because they're at the same reference location. So we don't usually compare, oh, it's 1, 2, 3. They actually, internally, it's just like, is it at the same place in memory? If it's at the same place, it must be the same thing. Now, with a string, we can't do that. We'll look at why in a sec. But with a string, the actual data, the object's value is going to be compared. So we should get a good comparison. So if you're in Java, you might run across some issues where Java doesn't do this. Sometimes we have to do some special things to compare strings. Within C#, it's a little bit more flexible and it'll take care of that for us. So it's going to compare those strings values lexicographically. I think that should be a G. So that means in alphabetical order. Now again, the string class has a lot of methods, and we want to be aware that string objects are immutable. So what does that mean? That means if I start out with this string named myString, and I give it a value of initial string, it's going to be allocated in memory, and these characters are going to be sitting there at that memory location that is referenced by my string's name. Now, if I change my string's value to another value, that original memory location is not going to be changed. A new memory location is going to be allocated with this value, and the reference to my string is going to be updated. So that means the myString variable is going to point to this value in memory now. This other value is still out there, just floating around in memory, just taking up space, because it's immutable. That means I can't change it once it's been allocated. So that's fine for this little teeny string. But what if I was updating, you know, like the company name on 1 million records? I could really run into problems with memory, right? And so it wouldn't seem like I should, because I'm just changing this name every single time. But as that information is copied into memory, it's made immutable. So we're going to create a new memory location and point to that. So we can get around this problem using a special class called the String Builder class. Now, String Builder offers a lot of the same methods as the regular string class, but it creates mutable strings, meaning they can be updated. So if we're using String Builder, we don't have to worry about changing all of those different strings in memory. So take a look at it again. For the assignment, you want to be aware of those different string functions. This one you guys all know about, right? Because like, I don't know if it's you guys or the other class or whoever all forced me and bullied me into using this last semester, thank goodness. So string interpolation is where we put the $ before the double quotes, and then within our string, we can specify our variable names directly within our curly braces. And this morning we were looking at some code that did the old comma replacement type thing, and I was like, what is that? It took me a second. JavaScript. Yep. String interpolation is what that is. Now, that was new with C# 6.0. Are we 7.0 now? 8.0? Sometimes I have a hard time remembering. I believe that was Visual Studio like 2014. So it's not that long ago. So remember, if you're in front of an oldie and you're typing this and they start having a little bit of a panic attack, say, oh, this is string interpolation. Have you never used it? Let me show you, and try to be nice. Just remember, they might not have ever seen it, because it was hard for everybody to get me to switch to it, and it's so much better. Do I? Oh, yeah, that should be last. It should be last. It's a typo in that whatever book I snagged that from. Okay, bit array. Now, a bit array is basically an array of Booleans. So I could say Boolean and make an array of Booleans, and I would be making it myself. But there's also a class available called a bit array, and it's going to have methods and things available to it that are going to help with its use. So a bit array is basically just an array that only takes 1 bit of storage for each entry. So each entry can have a value of either true or false. And a bit array is going to work great for things where you need to keep track of whether you've already used something. So one of the other teachers used to like to do a lottery ticket assignment, and they would say you had to have 7 different random numbers. They all had to be different between 1 and 45. So you could set up a bit array with your 45 entries. When you use number 6, you could change it from false to true. And then if you were going to use a number, you could check and make sure that it hadn't already been used. We're going to have an assignment coming up that is also fits really well with a bit array. This parking garage. So in this one, you're going to have like 25 parking spots that you want to keep track of. So perfect for a bit array, because if a car pulls into one of those parking spots, you can change its value from false to true that it's used. And then you can just keep track of everything. So easy that way. So bit array just uses a really small amount of space. A hash table is another type of object where we're going to create or try to take a value like this person's name and generate a unique key. Now we can see in this example, kind of like that other one, there's a problem with this hash index because John Smith and Sandra D ended up with the same key. We would have to fix our hashing algorithm for that, because we want to make sure when we're using a hash table that every entry comes up with like a unique key. So it's just kind of a way, almost a predecessor for the unique primary keys that we see in a database table. So a hash table generates a unique encoded or enkeyed value for each entry. Okay, we talked about a stack, got a little bit more about a stack. What about a queue? A queue, here's a queue. That's a queue. So a queue is English, British, right? And it's a British line. When they get in line, they get in the queue. And so, according to my daughter, who's traveled a lot, the Brits are just awesome at getting in line. And actually, there's been a lot of studies, and they say that Brits are very good at getting in line, and that they do a really good job, and they stay in line. And then I said this morning, I'm not sure if it's true, but I've also heard that, just to stereotype unfairly, that people that are from an Asian background are not so good at standing in line, that sometimes they like to get ahead in line. First of all, I don't know if that's true or not, but there are whole majors and research studies involved in queuing theory about those kinds of things. So like for this queue, would you get in this line? Would you wait in it? Depends. If it was something you wanted really bad, you might, but you would have to want it a certain amount, right? So how long are you going to wait in that line? That's another component of queuing theory. You know, how long would you wait? Because we all know all these things. How much do you think Walmart pays for all this queuing theory research? A lot. How long will those people wait to do a self-checkout? Not quite as long as they'll wait if somebody else is going to check them out. So there's a lot that goes on with the behind-the-scenes thinking about a queue. But if we're controlling a queue programmatically, when might we want to program a queue type structure? First in, first out. When would we have a line? Think of anything? Think of any? It's hard to think of them.
Like if you were creating a program where people were buying tickets for a concert or something?
That would work. So you've got a single thread. That purchase, you have to set that to where only one process at a time can update how many tickets are available, right? We have to single thread that because we can't update how many tickets are available from several different places. And so since that process is single threaded, the system could in effect create a queue. We might do it manually if we were wanting to give people that came from this site a higher priority than people that came from this other site. So that would be a good one where we would have our own queue. Sometimes in examples, they'll do stuff in queues where they're just like, you know, put it in there and take it out just to show the example that you know how it works. Now, when we're working with a queue, we've got our first in, first out algorithm going. When we add someone to the queue, add a new entry into our queue, that's enqueuing, right? And when that entry comes out of our queue, they're dequeued. out of the line. Now, before we dequeue something or someone, we can peek at it if we want to see what it is to decide what we're going to do with it. So those are standard methods that would be available for a queue structure. NQ, DQ, and peek. Now the stack I have a better example for. It's not necessarily a good example, but I've heard about it when somebody went to interview at one of the companies around town. They asked them how they could reverse their name without using a sort or without using a loop. And they said, oh, well, I could put each letter of my name, pop it into a stack, or push it into a stack and then pop it out, and it would be in reverse order. And so the story goes that they got the job because they knew about the stack structure. So anything like that where we want to reverse something, we could push it into the stack and then pop things out of the stack. And again, with a stack, we can still do a peek method. So anytime we're working with a stack, adding to the stack is a push, taking it off of the stack is a pop, and looking at an item without affecting its status in the stack is a peek. And MSDN has a ton of examples and things that you can look at for knowing about all of the different collection classes. Now, I was looking at our sort and I was trying to make it generic. So I added just the generic specifier of T to our sorter class. And I'll show you, like down in our print, it just works great. I could pass any data type in here as our array type and then print out all of those entries in that array using that generic clause. So everything's good there. There's a problem in the load though, because my generic specifier isn't going to allow me to use .next because that returns an integer. So there's some things that would have to be resolved. The other thing is it won't let us do the greater than if statement comparison because this is a generic object and it's not sure how to compare them. So we'd have a little bit of changes to do.
That's exactly what I was thinking, Scott. I was like, it's gonna suddenly not gonna want to do
Yeah,
it.
so there is stuff that's mad. You're right, you're right. So I just wanted to show you. I'm gonna try to resolve it if I can. I have that Explore OTC thing on Friday, so it's like taking up every moment. But hopefully I can see how to get those resolved and show you. But we will figure it out one way or the other. It's cool to use generics. So what we can do, let's go to the REPL. So go to Canvas if you haven't opened it yet. So your Pig Latin one is the one I was talking about, where you want to look at the string class and the string builder class. And you can save yourself so much time if you spend a few minutes looking at those before you start. You'll see what your capabilities are. But let's look at this REPL, be calm and collected. I'm just going to log in. And I think I've got to log in using my other account. Hang on, let me see if I can figure it out. Because I've already done these with the other class. Okay, so we have 8 assignments in this one. Did everybody find it? Got it okay? Found it. All right. There's other people, we won't give them any help. Bless you. Let's start on this first one. Okay, so we have a two-dimensional array here. So we got a color changing display here in this two-dimensional array. We can tell it's got some initial values already loaded. We want to use some of the array properties to output the size of the array. We're going to use the rank property to output the dimensions of the array, and the getLength method to output the number of rows and columns. So down here is our expected output. So I'm just going to add a new line right after this array declaration. Put in my console.writeLine. And the first thing it wants is total array entries equal. And then I'm going to add in display colors dot length. That sound right? Let's run it and see. Let you guys be getting all slacky with Visual Studio helping you all the time. Feels really weird when you start just typing all the code from scratch. Okay, that looks good. It says total array entries equal 12, like it wants in the instructions. So next, we need dimensions equal. Now, if you notice, I'm not using the interpolated strings because I'm afraid they might throw REPL for a loop. You can try it. Do they work? I didn't think they would work. So display colors.rank should give us the dimensions. Let's check. Yep, there we go. And then our number of rows. Okay, you say it works. I'm going to put it in this way then. So display colors.getLength, then what? 0. So it likes that, okay? I'm going to run it. I can't believe it. It's just going to be like summer where at 2 in the morning it decides it doesn't like it again. Like lambda expressions. One day it likes them, the next day it hates them. Okay, so the only other thing we need then is our number of columns. So get length 1. Oh, is that what my problem is?
So GetLength is like, tell me the links that only have one.
Mm-hmm.
And that's how I do it.
Different dimensions. So it would say 12 if we called it without a parameter, wouldn't it? The get length. Try it. I think it would be the same as the length, but I don't remember for sure. Nope, it just gets bad. Can't do that.
Because I didn't know the link one, so to get the total number of entries, there's
Yeah, so that can cause you some trouble. Okay, so has everybody got it? Does that one look good? Let's submit it. Let's see if it'll let me submit. It's mad about my FACO email address here. I had to do something. Okay, and me and several other people have requested that they put a next button here, but they just don't seem to care. All right, so that one's done. Let's look at our next one. In this one, we have the same array, and we have this list method now that's outputting stuff about our array, and we want to revise that method to output the information in the array like below. So we want to have a statement that tells us what row we're starting, and then a line for each column in that row. So if I look at the list color entries method that already exists, it is already writing out the row number. Let's run it and see what it's doing already. Right now, it's already doing most of it. It just needs a little bit more text to be added to the output. So we don't really need to add any additional output, just change what we've got. So let's fix that. Right here on line 19, where we're writing out the row, let's add some information to that. And we'll make it say begin row, and then our row number. I'm going to go ahead and test it. You know, when it's somebody else's code, just like, well, I think that should work. Oh, that looks right. Begin row 0. Okay. So then we need to alter this right line that's within the inner for loop, because that's the one that's generating each of the different colors. So instead of just outputting the column number, we need to output the word COL, then our column number, I'm going to get rid of this plus and stuff. After our column number, we want contains a value, and then finally our array entry. Does that look right? Oh, I need my closing double quotes. So I think that's right. This morning we did it, like I said, the old school way. So this actually looks a little different to me. So I think we're doing good there. Column number contains the value, and then our array value. So let's run it. That looks good. Now look at that array entry up above and notice how it's been declared. Whenever we're doing a two-dimensional array and we're allocating it, we start with our open and closing curly braces, and then each row has another set of open and closing curly braces. So C#, besides being strongly typed, that it likes to know what data type things are, it's also, I'm going to say, row dominant. So whenever we're using a two-dimensional array, the first index value is going to be our row value. Row, then column. And so that's how we have this array set up. So you can see we have an opening and closing curly brace for each row, separated by commas. That looks good. I think that everything's working there. I'll go ahead and test it. And if it's happy, submit it. So everybody's okay? Got it all right? That one's easy. Okay, so let's look at the third one here. Now in this one, again, we have that same two-dimensional array and our same method to print things out. We want to change our output a little bit. But in this one, we want to use a for each loop to output each of our entries. So let's change things up a little bit. I don't need any of this code at all, huh? So I'm just going to get rid of it. Okay, so in my for each loop, what data type am I going to be looking at for each entry in this array? String. So for each of those strings, let's call it, well, I don't want to call it color because that's kind of a reserve. We'll call it item in. Now, what's our array named in this method? Array. So for each item that is a string that's in this array, we want to do something. And what we want to do is a console.writeLine. And our output is going to be, let me interpolate it, entry, and then the item that we're looking at. So notice how much easier that is, because we got to get rid of 2 for loops and a set of nested for loops and replaced it with our for each command. Now notice also though, you're at the whim of the system. You can't update anything. You don't know what index you're looking at. So, you can only use this when it meets your needs. So let's run it, make sure it's working right. There's my output. I'm pretty happy with that. I think that's what we wanted. So I'm going to run the tests and submit it. Back to our class. Let's do a couple more together. Okay, so this one, again, we have our color array, and it wants us to replace that. So we want to replace the display colors array with a 2-dimensional array of integers. This array will contain 3 integer values for 4 days. So we're going to assign those values to our array. Then we want to replace the list color entries method with a method to output the new 2-dimensional array, and we want it to look like this with our integer values instead of those colors. So I don't want to call this display colors, and I don't want it to be string. So let's start at the beginning. I'm going to change string to int. I'm going to change my name to display ints. And now I want to set up my values. These are integers, so I'm not going to have any quotes. I'm going to do 43, 50, 21. Now remember, I'm just replacing what's already there, but I'm being very diligent to make sure that my opening and closing curly braces are correct. So my first row here has its own set of opening and closing curly braces and a comma to indicate that it was the first row or that additional rows follow. Okay, my second one then is going to be 18, 90, 77. So just like I'm going to have a comma in between rows, I've got to have a comma in between values. And the way we allocated our array and filled it with random numbers last time, that would be more common. So in a real world application, you won't see this kind of preloaded array very often. We use it a lot when we're learning. 11, 74, and 25. And then lastly, we want 93, 3, and 56. No comma after our last row, but our closing curly brace is followed by a semicolon, and that completes that line that allocates and initializes our array. Now I want to change the name of this method also to list int entries. And I want to pass our display ints array. So list int entries. I shouldn't have to change anything else, should I? So it look right?
Your string array next to list entries needs to be in.
Oh, good eyes. Does that do it? Looks like that does it. Looks very happy. I'm going to submit it. Perfect. Now the next one says to copy that code from the last assignment. We're going to use it to replace the main class in this assignment as a starting point. Now before you go copy, I'm going to read the rest of it. We want to add a new method that calculates the average for each of the days in the array. The method should expect an array of integers as a parameter and to return a one-dimensional array containing the average for each day. So when you create this average method, you should declare an integer to hold your sum, declare a one-dimensional array of integers to hold the average for each day, use a for loop to process each row, use an inner for loop to process each column. When you're processing your columns, add the amount to the sum. After you've processed the columns for that row, calculate the average for this day, save it in the one-dimensional array, and reinitialize your sum. So your output should look like our previous, but then it's going to have additional output here with our averages. Now let's go back and look at the others, because I'm going to leave you on your own there, starting there. Let's look at the ArrayList class. Now the one for the ArrayList class has already created an array list. Wants you to create a method to display the contents. So the output should look something like this from your method. It's already being called there. So that's our array list. And then let's look at the string and bit array. So this program processes a list of names to determine which names contain the letter A. Right now, the output is the list of names followed by a true or false status. So if you run the program, let's run it, should see our different names, whether or not they contain an A. Do you see a problem? They do. They want it corrected because they want Amy to show as true. So we need to update this program to allow a capital A to be considered as an A. So that's that one. And then lastly, we start out with a basic Hello World main class. So this one you might want to do in Visual Studio and then copy over. It's kind of up to you. But on this one, you're going to write an application that creates a two-dimensional array. You're going to prompt the user to input the size of the array, the rows and columns. Fill the array with random numbers between 0 and 100. So it's going to be a lot like the sort load array method we did last time, but a little different because it's going to be doing a two-dimensional array with numbers that were prompted for the user. Then after the array is built, you need to search it for the largest value, display that value, and the index, all of the index locations where that value was stored. Now for this one, there's no specific output requirement, so you can output it however you want. Because you're using random numbers, you're not going to match any output, so you're just going to have to force submit this one, and then I'll be looking at it manually to complete it. So don't worry, that one will have to be that way. So that means if you have questions on any of these, don't forget, submit them, and then send me a message in Discord or something and tell me you had a question that you submitted. Since we have one where you have to submit with it not matching, I won't look out here unless you guys tell me that you have a question, because this one definitely won't match up. Okay, those are the ones for you to finish up on your own. We have, I bet you can get pretty far today before we run out of time. Any questions? Now let me know if you run into anything. We fixed a couple of things this morning, so you guys are lucky. There was a couple of weird areas.
I'm not too bad. You can read